Hi, grade 11s. Today we'll do some revision on the grade 11 hyperbolas. You will recall from grade 10 that your hyperbolas look like this. If that is a negative number over x, y equals negative number over x, the arms of a hyperbola will be on the second quadrant and the fourth quadrant. If y is equal to 5 over x, or a positive number over x, your arms will be the positive in the first quadrant and third quadrant. Obviously, we will also have the asymptotes here, meaning that your graph, the arms, will never cut the asymptotes. So we are also able to shift the graphs either up or down. For instance, the graph of y equals 3 over x plus 1 will have our horizontal asymptote shifted up by 1 unit. So I've got a plus 1 there, so we knew that there will be a horizontal asymptote now at y is equals to 1. Obviously, we could have shifted it down units, some units down, then we'll have minus, say, minus 1 or minus 3. Then we also recall that there is also what we call the axis of symmetry, meaning if I were to draw a line over here like this, I could fold this arm and it will lie on top of this, and the equation of this is y is equals to x. If it's landing like that, such that if I fold here like so, so that one will be y is equals to minus x. Is passing through the 0 where the asymptotes meet. Okay, now let's look at some examples. Suppose we are expected to sketch the graph of f of x equals 6 over x minus 1 plus 2. And the question is, what is the vertical asymptote of this function? So to find the vertical asymptote of this function, remember that we take this, which is x minus 1, we equate to 0, so then x is equals to 1. So that would be the vertical asymptote of this graph, meaning that if I were to draw this graph at x equals to 1, I'll have a vertical asymptote. If I were to draw it like this, I will have a vertical asymptote of this graph at x is equals to 1. Next, the horizontal asymptote. The horizontal asymptote will simply take this over here. So that one there will be your horizontal asymptote. Then just say y is equal to 2. The line y is equal to 2 will be your horizontal asymptote. The line going through like that, the horizontal asymptote goes something like that. Remember that we are trying to draw the graphs that look something like this. That's a positive 6, so it will be like arms like this, and that it will be there and there. The next thing will be to find the y-intercept. To find the y-intercept, you always make x equals 0. There is an equation, so you must make x 0 over there. So therefore, I can say now f of x is equal to 6 over 0 minus 1, then plus 2, so which means that the answer will be a minus 6 plus 2, which will equal to minus a 4. So therefore, my y-intercept is at minus 4. So I've got my y-intercept at minus 4. The graph cuts here somewhere at minus 4. Let's say maybe we put a point there, and that will be at minus 4. So we'll have a minus 4 there. So the graph will cut in there, somewhere there. The next one is to work out the x-intercept. Now to find the x-intercept, that is when we make y 0. So this is why we make the y 0. So now I've got now 0 is equal to 6 over x minus 1, then plus 2. Now I'm solving for x, so I can take this across. I've got a minus 6 over x minus 1, which is equal to 2. I can cross multiply. Minus 6 is equal to, cross multiply is 2x minus 2. Take this across, you'll get a minus 4 is equal to 2x. So x is equal to minus 2. So when x is minus 2, if that x is minus 2 over there, say this minus 2, that is where the graph will cut. Now I can sketch my graph. So my graph now will look something like this to cut through the y-intercept over there, and then I'll have my other arm over there. So I've got my graph there. That's it. The next one. Next question says now, The graph of h, it's a new graph now, is formed by shifting the graph of f by 3 units down. Let's say I take this graph of mine, I shift it 3 units down. Remember that this one here is at 2. So I'm shifting this thing here 3 units down. So this is 2 units, then 1 unit would make 3 units. So it means that now I'll have it, the arm will be there to create that line will be there, and then the graph will be down there. So I've shifted it, so it means that the horizontal asymptote will be at -1. So that would be a -1. Therefore, the equation, give the equation of h now, it will be h of x is equal to 6 over x minus 1. Then we said shift it to -1 there. I put -1. That's a new equation. Let's look at another example. Another example says here, now the graph is drawn for us. They say find the equation of f, there is a f there, in the form f of x equals a over x plus p plus q. Remember, always make sure that your a value is the last thing to find. So the things that you must fill in first are these things here. The first one is q. Remember, q is our horizontal asymptote. Q is our horizontal asymptote, which is -1. So we know that we've got -1 there. If I can start here and say f of x is equals to a, which I don't know, let's say it's x plus p, and then we say -1. Okay, now let's look at p. Now p is about the horizontal asymptote. Remember, to find the horizontal asymptote here, we took this and then we solve for x. So we take this, we solve for x. When we solve for x here, this was x minus 1 equals 0. We got x equals 1. So that was x equals 1. But here, or under the bracket of the division sign, there was x minus 1. So if that is 1, so it would be x minus 1. If that was 5, it would be x minus 5. Therefore, now in this case, we've got this is -2. So under the bracket, it will be x plus 2, meaning under the division line, it will be x plus 2. So therefore, my equation now is f of x is equals to a over x plus 2, then -1. Now the last thing to find is to find the value of a. To find the value of a, use any other point which is on the graph of f. There is no point here. There is a point over here. The coordinates of this point, note the coordinates here. X is 0, y is -3. So when x is 0, y is -3. So I can plug that. That is -3. And this a, when x is 0, so it's 0 plus 2 minus 1. So -3 is equals to a over 2, because 0 plus 2 is 2. So -1. I'm solving for a. I take -1 across. So it becomes a -2 is equals to a over 2. I'm solving for a. Cross multiply. I get a equals to -4. Now I know a is -4. I can plug it back there. So therefore, f of x is equals to a -4 over x plus 2 minus 1. Here's another one. Now they say, find the equation of the axis of symmetry of the graph that has a positive gradient. Remember that we said the axis of symmetry is a line that we can draw cutting through that line there. But they said it must have a positive gradient, meaning that that line must have a positive gradient. It must go through like that. Let me just draw it. I'm not supposed to draw it, but just to make things easier. So they said the gradient is positive, so it's easier for us to get that. Let's start here. Y is equal, so it's a positive gradient, we just say x. If it was a negative gradient, we say negative x, right? But what we don't know is the y-intercept, is the c value. So we want to find the c value. To find the c value, substitute the point where this line is cutting. The point, that is point A, and the coordinates of point A are the x is -2 and the y value is -1. X minus 2 is -1, so -1 is equals to x, which is -2, and then plus a c, which means that my c value, take this across, with a 2 minus 1, which is 1. Therefore, the equation they are looking for is now y is equals to x then plus 1, like that. That's so easy. Now let's try and do this. So I suppose these problems will be easier for you to do, because it's just like a revision. So make sure that you discuss with the group, you find somebody to work with, and then you discuss questions, because some are put such a way that it can be a little bit confusing. But if you discuss them, and then it becomes easier for you to do them. Okay, good luck. So the work is from the Brighter Future website. grade 11, 8 to 11 papers, grade 11. Then you do DBE paper 1 2015 and 2013, and then Eastern Cape 2015, and then the questions of question 5, question 11, question 7, and question 5. Good luck.